Hello, this is Mrs. Ward, and I am going to go over the first two examples in section 10.5, rotation of conics. So what we're going to do in this section is we're going to take all the information we learned in 10.2 through 10.4 with the parabolas, ellipses, and hyperbolas, and we're going to take these shapes, which at this point have always been parallel or perpendicular to the x and the y axis, and we're going to rotate them. So remember when we were in the end of section 10.4 with the hyperbolas, we learned how to classify conics, and when we looked at that, we looked at the a and the c terms of, or whatever was squared, and you should have noticed that we didn't have the letter b, and the reason we didn't have the letter b is because we skipped that term. We skipped the term that has a bx, or in other words, it has both an x and the y in it. So we skipped this step, this term, and the reason why we didn't have that term is because once I have that term, that means my transversal axes are no longer parallel and perpendicular to the x-axis and the y-axis. So when I have this bx term, that means that I am going to rotate it. So what I'm going to do is I'm going to figure out the angle of rotation. And once I figure out the angle of rotation, I'm going to rotate my axes, create a new coordinate system, and then graph my conic based on that new coordinate system. So we're going to figure out this angle of rotation, and remember, we're always going to, do a trig angle, and we're going to rotate counterclockwise. And we're going to, and when we do this, we are going to do what's called eliminate the xy term. So when we eliminate the xy term, that means we're going to pick up our axis and we're going to rotate it. And what you're going to do at home when you go to graph these and graph these points or graph whatever, is it's like you're going to pick up this whole graph and you're going to turn it so that your new axis is parallel and perpendicular. So that you would graph off of this axis instead of the original one. So let's first see what we're doing. So you will have a formula sheet for this. You're going to rotate axes. So what I'm going to do is I'm going to rewrite it so that I lose that bx term. I eliminate the bx term. And notice when I do that, I write, I'm going to have a coefficient of a, but it's not going to be the same number, obviously. So I'm going to have these little prime numbers, which means that it's a different a different b, a different c. But this formula eliminates that bx term. This is when I rotate the axis. So the first thing I have to know is I have to know what angle I'm going to rotate. And to figure out what angle I'm going to rotate, I'm going to use this formula here where I have the cotangent of 2 theta is equal to a minus c, and that's all over b. And then once I figure out the angle, I'm going to put that angle in here for this formula here, and this will be how I rewrite my x, and this will be how I rewrite my y. So I think it makes a lot more sense if we try and do a couple. We're only going to do baby ones today and see how it goes. So the homework for 1 through 6 says the xy coordinate system has been rotated theta degrees. So what that's telling me is that my coordinate system has already been rotated 60 degrees in this example. From the xy, the coordinates of the point in the xy coordinate system are given. So this is a point in the normal xy system, and I want to find the new points. So find the coordinates of the point in the rotated coordinate system. So the points in the rotated coordinate system is at x prime or y prime, and that's what I'm looking at. So basically what is happening here is you have your normal xy axis. They're telling me that I'm rotating that 60 degrees, so I'm going to do my best to have a 60-degree rotation. And I want to make this one perpendicular. So this is going to be my new x-axis, this is going to be my new y-axis, and this is my rotation of 60 degrees. Now I have this point 3,1. This 0.31. So if I were to graph it on XY, I'd go 1, 2, 3, go up 1, and I would plot that point about there. So that would be the point. Now I'm just going to have that sit over there while I do the rest of the work. So the first thing I'm going to do is I am looking for my new x prime and my new y prime. So I'm going back to these formulas here, and I'm going to substitute in what I know. So I have x is equal to x prime cosine theta minus y prime sine theta. That's the formula for x. So now I'm going to substitute in what I know, and I know what my x is 3. I'm looking for x prime. My cosine of theta, so the cosine of 60 degrees, can I put 60 degrees in there? The cosine of 60 degrees is 1/2 minus y prime, and the sine of 60 degrees is the square root of 3 over 2. So when I have that, when I simplify that, I'm going to have 3 is equal to 1/2 x prime minus the square root of 3 over 2 y prime. So that's my x. Now I'm going to switch colors and I'm going to do my y. So my y is going to be y is equal to, that formula is x prime, and then the sine of my angle. So I'm going to go ahead and write sine of 60 degrees plus y prime cosine 60 degrees. So then I'm going to substitute in what I know, and I know that my y is 1. 1 is equal to the sine of 60 degrees is the square root of 3 over 2, and the cosine of 60 degrees is 1/2. So now I have an x prime and a y prime that are unknown, but I have two equations, so I have a system. So I'm just going to write the red one right underneath here. And then I have to ask myself, I have to solve the system. So I'm going to solve it by multiplying. Since the y's already have opposite coefficients, I think I'm going to multiply by, I think I'll multiply this one by the square root of 3, and that way I can eliminate the y. So if I do that, the blue one's going to stay the same. So 3 is equal to 1/2 x prime minus the square root of 3 over 2 y prime. Now I'm distributing the square root of 3, so the square root of 3 is equal to, the square root of 3 times the square root of 3 is 3, so that's going to be 3/2 x prime plus the square root of 3 over 2 y prime. Now when I add, these will drop out, and I'm left with 3 plus the square root of 3. Cannot simplify that, cannot combine them, not like terms. This will be 4 over 2, or 2x prime, which means that 3 plus the square root of 3 over 2 is equal to my x prime. So now I have x prime. I can substitute it back into either one to find my y prime. And I'm probably, decision. Let's go ahead and put it back in here, I guess. That makes sense. So I'm going to have, so 1 plus the square root of 3 over, I'm sorry, that's 1 equals. 1 equals the square root of 3 over 2 times x, which I just said was 3 plus the square root of 3 over 2 plus 1/2 y prime. So 1 is equal to, distributing the square root of 3, I'm going to have 3 square roots of 3 plus 3, because it's square, all over 2 times 2 is 4, plus 1/2 y prime. So I am going to subtract this from both sides. So when I subtract this from both sides, I'm going to make this 4 over 4 so they have a common denominator. So I'm going to have 4 minus 3 times the square root of 3 minus 3, distributing that negative sign, all over 4 is equal to 1/2 y prime. Then when I'll have 1 minus 3 times the square root of 3 over 4 is equal to 1/2 y prime. To solve this, I'm going to multiply both sides by 2. When I do that, this will become a 2, and I'll have 1 minus 3 times the square root of 3 over 2 is equal to y prime. So my new order pair is going to be 3 plus the square root of 3 over 2. That's my x, and then 1 minus 3 times the square root of 3 over 2, and that's going to be y. And give me 1 second. So what I did there is I changed them to decimals. I want you to leave it like this, but I want to show you what's going on. So this decimal approximation for this is about 2.4. That's a lot of rounding, but close enough. And this decimal approximation for this is going to be negative 2.10. So if I have that, if I were going to plot it, I'm going to go plot it, but I'm going to plot it on my rotated coordinate system. So what you're going to do at home is you're going to pick up your paper and you're going to rotate it I cannot pick up my paper and rotate it, so I am going to grab this picture that I made, and I am going to rotate it so that the new x-axis is horizontal, and then the y-axis is perpendicular. Now, if I were going to graph this point 2.4, negative 2.10, I would go over on this new axis, see, this one that has been rotated, I would go over about 1.2 and then about 2 something, and I would end up at the same place. And that's the whole point of rotating, to eliminate. When you rotate the axes, you have to be able to identify the points on that new axis. So it's basically like you're creating a whole new coordinate system for this point. So let's try and do an actual equation. So I have, it says write the equation xy plus 2 in standard form. So if I have something like this, the first thing I have to do is I have to figure out how much I need to rotate my axis to eliminate the xy term. Now, this is actually understood to be like 0ax squared plus 1b, oh, that'd be b. The a would be 0. Here the b would be 1. And then xy. And then my c is going to be 0. So when I do that formula, cotangent 2 theta is equal to a minus c over b, I am going to have 0 over 0, which is 0, divided by 1. It just cannot be undefined. So I am going to have the cotangent of theta is equal to 0 minus 0 over 1, which is 0 over 1, which is just 0. So then I have to ask myself, when is the cotangent equal to 0? And hopefully you remember your trig, and you say, well, gee, Mrs. Ward, I know that happens when x is equal to 90 degrees. But I didn't have just one theta. I had 2 thetas. So I'm going to say the cotangent of 2 theta is equal to 90 degrees. So that means the cotangent of 2 theta is equal to 0. I'm so sorry. 0, which means 2 theta is equal to 90 degrees, which means 1 theta is equal to 45 degrees. So what that means is when, in order to eliminate this xy term, if I have my x-axis and my y-axis, x and y, I'm going to have to rotate this axis 45 degrees. And that's about as good as 45 degrees as I can get. So this is going to be 45 degrees. And when I rotate it 45 degrees and I do all the math, that xy term should disappear, and I should be left with like something x squared, something y squared. Maybe, you know, changing my center. I don't know. I'm going to just do it. So here we go. So I'm following the formula that I did before, except for now I'm rewriting. So I'm going to say x is equal to, it's x prime cosine 45 degrees minus y prime sine 45 degrees. And here's a little note. If you're checking your answers in the back of the book, they're going to, here's my little side thinking note. When you're checking your answers in the back of the book, when they do cosine of 45 degrees, they're going to write 1 over the square root of 2. And they all write. That is what it is. But you have been trained to rationalize, so that's why you write the square root of 2 over 2. Either one can work. I'll stick to this because that's what we taught you. But if you want to change that to 1 over the square root of 2, it does simplify your math. You might want to do that. So x is equal to, that x prime is going to stay here. The cosine of 45 degrees is the square root of 2 over 2 minus y prime, the sine is the square root of 2 over 2. So that means x is equal to the square root of 2 x prime over 2 minus the square root of 2 y prime over 2. And I like to put them all in, I like to have like a fraction and fraction. So that's my x. Now I'm going to find my y. So my y is x prime sine 45 degrees plus y prime cosine 45 degrees. So when I do that, y is going to equal the square root of 2 x prime over 2 plus the square root of 2 y prime over 2. I skipped that middle step because it's the same. So I have my x and I have my y. So then I go back up to my equation, and my equation is x plus xy plus 2 is equal to 0. So my equation is xy plus 2 is equal to 0. I'm just going to get that 2 out of the way and say xy is equal to negative 2. Now what I'm going to do, and this is where the fun begins, is I am going to take my x, which I said this is what my x is equal to, and I'm going to put that in for my x. And then you should be thinking, well, gee, Mrs. Ward, if that's what I'm going to do for my x, then I'm going to take this, which is my y, and I'm going to put that in for my y. And then I'm going to FOIL them. That sounds like so much fun. Let's just get started. All right, so here we go. So my x is that square root of 2 x prime over 2 minus the square root of 2 y prime over 2. That's my x. My y is the square root of 2 x prime over 2 plus the square root of 2 y prime over 2. And this whole thing is equal to negative 2. Now I'm going to FOIL. Hopefully you recognize it as, hopefully you recognize that this is the same term as this, and this is the same term as this, and one has a minus sign and one has a plus sign. So that's the way that you factor the difference of two perfect squares. Maybe you recognize that, maybe you didn't, but here we go. If I'm FOILing, I'm going to take the square root of 2 x prime over 2 times the square root of 2 x prime over 2, which will end up being 2 x prime squared over 4. Then this will be 2 xy over 4 negative, and this will be 2 xy over 4 positive, so that middle term will equal 0. And now I'm finally going to do my last term, which means I'm going to multiply the two blues, which means I'm going to have a minus because I have a negative times a positive, and 2y prime squared over 4, and this is going to equal negative 2. So you should realize, I'm hoping you realize, that this will be x prime squared over 2 minus y prime squared over 2 is equal to negative 2. I just simplified these. Now, it's a conic. A conic has to be set equal to 0, and this should look familiar to you. In order to set it equal to 0, I would have to divide by negative 2. So in order to divide by negative 2, you can either think of dividing it by negative 2, or you can think of multiplying everything by negative 1/2. Either way, if I divide this by, see, I hate writing it like that. I'm not going to do it. You can't make me. You're not here. So I'm going to think of this as multiplying by a negative 1/2, multiplying by a negative 1/2. When I do that, I get x prime squared over 4, but that's now negative because negative times a positive. And now this negative times a negative makes this a positive. Y prime squared over 4 is equal to 1. And so I don't mess it up. I can plainly see it's a hyperbola because one is positive, one is negative. I'm going to write the y prime squared in the front because that's the positive one, and then the x prime squared over 4 as the second one because that's the one that follows the negative sign. Now, going back to a hyperbola, I know that my center is 0, 0. I know that my A is 2, so my vertices will be adding to the y. My vertices will be 0, 2, and 0, negative 2. And then I know I don't really care about my foci. I said it out loud. I'm not going to worry about that when I rotate. And when I go to draw this box, because I'm going to make my box for my asymptote, my B is going to be 2. So I know I'm going to go up to, I'm going to go left. This is going to be up and down 2. This is going to be left and right 2. So now I'm going to go way back up to that picture that I originally drew at the beginning of this. So going here, this is my beautiful picture where I was rotating my axes. I'm going to grab it, and I'm going to bring it down here with me. Come on, here you go. And in order to graph this, I am going to rotate it so that the new axis is new axes like that. So on my, like, you're going to actually physically pick up your piece of paper and turn it. And now, when I do that, this is my new x. This is my new y. This is what I'm graphing in my new x and my new y. So I know my center 0, 0, so that's going to be here. I know my vertices are up to 1, 2, down to 1, 2. So here are my vertices. Then I'm going to draw my box. To draw my box, I'm going to do that in highlighter, so I'm going to have a lot of ink here. I'm going to go 2 to the left, 2 to the right, and then when I make my box, then I do my asymptotes, and if I drew it correctly, because it's a 45-degree angle, those asymptotes are going to be my original XY, axes. So now I am going to sketch. So here's my vertice, and I'm going to follow those asymptotes. And that's my sketch, and I sketched this, the red, based on what I learned back in the first half of chapter 10, but the only thing is I had to first rotate the axis to make that happen. Now I'm going to grab this and lock it all up so it all comes with me, and then if I turn this back to the way it originally was, where x was x and y was y, that is what I have. So it does look like a hyperbola, it's just rotated. And that's a baby one, and that's how we do it. And I hope this helps, and we'll do a lot more in class. See you soon.